What if the most terrifying place in our solar system isn't a black hole, isn't Jupiter, isn't even the sun, but a frozen world so distant that sunlight takes more than 5 hours to reach it? A place where mountains are made of water as hard as granite, where glaciers flow without melting, where the atmosphere appears and disappears like a ghost, and where every answer scientists uncover seems to create 10 new mysteries. What if Pluto isn't simply the planet we demoted, but one of the strangest laboratories in the universe, quietly challenging everything we thought we understood? For most of human history, Pluto did not exist, at least not in our maps. The outer edge of the solar system ended with Neptune. Beyond that lay only darkness and speculation. Then in 1930, a young astronomer named Clyde Tombaugh changed everything. Working tirelessly at Lowell Observatory in Arizona, Tombaugh spent months comparing photographic plates, searching for a tiny object that shifted ever so slightly against the fixed background of distant stars. It was painstaking work. Thousands of stars, hours of concentration, one blink at a time. Finally, he found it. A faint moving dot. Humanity had discovered a new world. The newspapers celebrated. School children memorized its name. The solar system suddenly felt larger than ever before. For decades, Pluto became the mysterious frontier. It was small, cold, far away. Nobody knew what it looked like. Even through the most powerful telescopes, it remained little more than a blurry point of light. Scientists could estimate its size, calculate its orbit, measure its brightness, but Pluto itself remained hidden. Like a locked room at the end of the solar system. And sometimes locked rooms hide remarkable secrets. As telescopes improved, another surprise emerged. Pluto wasn't alone. In 1978, astronomers discovered Charon, its enormous moon. But Charon wasn't just another satellite. It was unusually large compared to Pluto. So large, in fact, that the two bodies orbit a point located outside Pluto itself. Instead of one object dominating another, the pair performs an endless gravitational dance around a shared center of mass. Some scientists even describe Pluto and Charon as a double dwarf planet system. Already, Pluto refused to behave like anyone expected. Yet an even bigger surprise was waiting. As the decades passed, astronomers began discovering more icy objects beyond Neptune. Hundreds became thousands. Eventually, an entirely new region of the solar system emerged into view. Today we call it the Kuiper Belt, a vast population of frozen worlds stretching across billions of kilometers. Pluto wasn't the edge of the solar system after all. It was merely one member of an enormous family. This discovery sparked one of the greatest debates in modern astronomy. If Pluto was a planet, then should every similar object also become a planet? The question wasn't emotional, it was scientific. In 2006, the International Astronomical Union introduced a formal definition of a planet. To qualify, a body must orbit the Sun, possess enough gravity to become nearly spherical, and clear its orbital neighborhood of comparable objects. Pluto met the first two conditions. It failed the third. The announcement shocked the public. People argued. Teachers rewrote textbooks. Some felt Pluto had been unfairly stripped of its identity. Others believed science had simply become more precise. Leonard Susskind has often emphasized that science isn't about protecting old ideas. It's about allowing evidence to reshape our understanding of reality. Definitions evolve because knowledge evolves. Nature itself doesn't care what labels humans assign. Whether we call Pluto a planet or a dwarf planet changes nothing about what Pluto truly is. And what it truly is may be stranger than almost anyone imagined. For decades, scientists knew almost nothing about its surface. Everything changed on July 14, 2015. After traveling nearly 10 years across almost 5 billion kilometers, NASA's New Horizons spacecraft raced past Pluto at more than 14 kilometers every second. There would be no second chance, no orbit, only one incredibly fast encounter. For years, engineers had prepared for a flyby lasting just hours. As New Horizons approached, humanity waited. Then the images arrived. Instead of an ancient, heavily cratered frozen rock, Pluto revealed a surprisingly youthful face. One enormous bright region immediately captured the world's attention. A giant heart. Officially called Tombaugh Regio, in honor of Pluto's discoverer. The heart became one of the most recognizable landscapes ever photographed beyond Earth. But its beauty concealed profound mysteries. The western half of this heart, Sputnik Planitia, appears astonishingly young. Based on the scarcity of impact craters, many planetary scientists estimate that parts of its surface are less than about 10 million years old, a remarkably recent age on geological timescales. Something had erased older craters. Something was reshaping Pluto. But what? On Earth, mountains rise because tectonic plates collide. Volcanoes erupt because molten rock reaches the surface. Rain and rivers sculpt landscapes over millions of years. Pluto has almost none of these familiar ingredients. Its average surface temperature hovers near minus 230 degrees Celsius. Water behaves like solid rock. Nitrogen freezes into ice. Carbon monoxide becomes frost. The laws of geology still operate. But the materials have changed completely. Imagine replacing every mountain on Earth with frozen water harder than granite. Imagine glaciers made not of water but of nitrogen. Imagine valleys carved not by flowing rivers but by ice that slowly creeps across the landscape despite temperatures capable of freezing almost anything solid. That is Pluto. Sputnik Planitia itself is filled with nitrogen ice. Unlike ordinary ice cubes in your freezer, nitrogen ice at Pluto's temperatures can slowly flow over immense periods of time. It behaves almost like extremely cold toothpaste. The result is one of the largest glaciers ever observed in the solar system. Except this glacier isn't made of water. It is made of frozen gas. Even stranger, scientists see giant polygon-shaped cells covering much of the plain. Each stretches for tens of kilometers. Researchers interpret these patterns as evidence of convection. Heat slowly rising from Pluto's interior may cause warmer nitrogen ice to rise while colder material sinks. The process resembles the slow circulation inside a pot of thick soup. Except each circulation cycle could take hundreds of thousands of years. An entire landscape quietly breathing beneath the frozen sky. How can a world so small remain active after billions of years? That question reaches beyond Pluto itself. It touches one of the deepest mysteries in planetary science. Where does internal heat come from? Large planets retain heat because of their enormous size. Radioactive elements inside rocky worlds release energy over immense timescales. Tidal forces can generate heat in moons orbiting giant planets, but Pluto seems too small for sustained geological activity. Some scientists propose that radioactive decay inside its rocky core still provides enough warmth. Others suggest that an insulating layer beneath the surface helps preserve heat far longer than expected. Current evidence supports internal heat playing an important role, but researchers continue debating exactly how Pluto maintains such an unexpectedly dynamic landscape. Every new answer opens another question. Then came the mountains. Towering peaks several kilometers high surround Sputnik Planitia. At Pluto's temperatures, ordinary rock would be buried beneath thick layers of ice. Instead, these mountains consist primarily of frozen water. On Pluto, water ice is the bedrock. Nitrogen ice flows around these mountains the way glaciers on Earth flow around rocky peaks. The familiar has become alien. The impossible has become ordinary. Then scientists notice something even more surprising. Some enormous structures resemble cryovolcanoes. Unlike volcanoes on Earth, cryovolcanoes don't erupt molten rock. They may release slushy mixtures of water, ammonia, or other volatile substances. Evidence on Pluto suggests that giant domes such as Wright Mons and Picard Mons could have formed through cryovolcanic processes, although researchers continue investigating exactly how these remarkable features developed. If confirmed, Pluto may possess a form of icy volcanism unlike anything early astronomers ever imagined. Now the story becomes even stranger. Pluto has an atmosphere, not a thick atmosphere like Earth's, not even one like Mars. Its atmosphere is incredibly thin, mostly nitrogen, with smaller amounts of methane and carbon monoxide. But this atmosphere behaves almost like a living thing. As Pluto travels around the Sun on its highly elongated orbit, sunlight changes dramatically. When sunlight increases, surface nitrogen sublimates directly from ice into gas. The atmosphere grows. When Pluto moves farther away, temperatures fall. Much of the atmosphere freezes back onto the surface. Imagine Earth's entire atmosphere collapsing into snow every winter and returning every summer. Pluto performs a version of this extraordinary cycle across decades. Even New Horizons discovered surprises here. Scientists expected the atmosphere to fade gradually into space. Instead, they observed spectacular layers of bluish haze extending hundreds of kilometers above the surface. Sunlight interacting with methane molecules produces complex organic particles called tholins. These particles slowly drift downward like microscopic snow. Over immense timescales, they may paint parts of Pluto in shades of reddish-brown. Ironically, one of the darkest worlds in the solar system manufactures color from sunlight almost too weak to feel. Distance itself becomes difficult to comprehend. At Pluto, the sun still appears astonishingly bright compared with the full moon seen from Earth. Yet it is only a tiny fraction as intense as the sunlight warming our planet. Shadows remain sharp. Daylight exists, but everything feels permanently trapped inside an endless winter afternoon. Standing there, you could block the sun with your thumb. Earth would be invisible. Human civilization would disappear into the darkness. Isolation becomes almost physical, and yet Pluto refuses to be alone. Beyond it stretch countless other icy bodies. The Kuiper Belt continues outward. Farther still lies the distant Oort cloud, believed to be the birthplace of many long-period comets, though it has never been observed directly. The solar system does not end where our childhood textbooks said it ended. It fades gradually into a vast population of frozen remnants left over from planetary formation more than 4.5 billion years ago. These distant objects preserve clues from the earliest history of the solar system, like fossils locked inside ice. Leonard Susskind often reminds audiences that understanding the universe requires recognizing that today's mysteries become tomorrow's laboratories. Physics advances by confronting anomalies rather than avoiding them. Pluto is precisely such an anomaly. Every expectation scientists carried into the New Horizons mission was challenged. A geologically dead world became surprisingly active. A featureless sphere became astonishingly diverse. A forgotten dwarf planet became one of the most scientifically valuable destinations ever explored. Yet Pluto also forces us to confront something even larger: the limits of human intuition. When we imagine geology, we think of lava. When we imagine weather, we think of rain. When we imagine glaciers, we think of water. Pluto demonstrates that nature possesses far more imagination than we do. Replace water with nitrogen. Replace liquid oceans with frozen plains. Replace volcanoes with cryovolcanoes. Keep the same physical laws. Change only the conditions. Entirely new worlds emerge. That realization echoes throughout modern physics. Suskind's work in theoretical physics repeatedly emphasizes that reality often appears stranger than common sense predicts. Quantum mechanics challenged classical intuition. Black holes transformed our understanding of information. String theory proposes mathematical structures existing far beyond ordinary experience, though it remains an active area of theoretical research rather than an established description of nature. Again and again, progress begins when intuition fails. Pluto teaches the same lesson from a planetary perspective. The universe is not obligated to resemble Earth. It is free to invent possibilities we never imagined. And there may be one more astonishing possibility. Some planetary scientists have explored whether Pluto could still conceal a liquid ocean beneath its frozen crust. This idea remains a scientific hypothesis rather than an established fact. Models suggest that radioactive heating combined with insulating ice layers might allow liquid water to persist deep underground despite the brutal surface cold. If such an ocean exists, it would likely be buried beneath many kilometers of ice, completely isolated, hidden from sunlight for billions of years. The thought is extraordinary, not because anyone has discovered life there. There is currently no evidence that Pluto hosts life. But because liquid water existing in one of the coldest regions of the solar system would dramatically expand our understanding of where potentially habitable environments might exist. Habitability is no longer just about distance from the sun. Internal energy matters. Chemistry matters. Time matters. The universe may create hidden environments in places once considered impossible. That realization extends far beyond Pluto. Moons like Europa and Enceladus already demonstrate that oceans can exist beneath frozen surfaces. If Pluto joins that family, then icy worlds become even more compelling targets for future exploration. The greatest discoveries may not lie on warm planets. They may wait beneath frozen shells. Even New Horizons did not finish the story. It merely opened the first page. Because the spacecraft never entered orbit, scientists observed only one hemisphere in high detail. Much of Pluto remains only partially mapped. Many questions remain unanswered. How active is its interior today? How thick is its crust? How stable is its atmosphere over centuries? Did Sputnik Planitia help reorient the entire dwarf planet through its immense mass? Researchers continue exploring these questions using New Horizons data, Earth-based observations, improved computer simulations, and future mission concepts. One flyby transformed Pluto from a blurry dot into a world. Another mission may transform it again. Perhaps the most unsettling lesson isn't about Pluto itself, it's about us. For 75 years, humanity confidently described a world we had never truly seen. Then a single spacecraft arrived. Within hours, decades of assumptions collapsed. Reality turned out to be richer, stranger, and more beautiful than imagination. That pattern has repeated throughout the history of science. Every frontier we finally reach becomes more complicated than expected. Every mystery solved reveals deeper mysteries beneath it, which raises a final thought that reaches far beyond Pluto. If a tiny frozen world at the edge of our own solar system could overturn so many assumptions after just one brief visit, then when we eventually stand before the countless unexplored worlds orbiting distant stars, how many of our deepest beliefs about planets, physics, and even our place in the universe will quietly dissolve into the dark, just as Pluto did the moment we finally learned to see it?